Alright, so here we are doing the review for the Calculus Intro chapter here. Now, this first page is all a bunch of limits that we've done. Now, you don't have to do every problem on this page. I'm going to go and do every problem, but you could just skip around, maybe pick half of them to go and do and try to get a little bit of everything. Alright, so this first one, remember the easiest thing you can do, or the easiest situation you could have, is literally being able to just plug in the number. So you can plug in 2 in all these places and just get the answer. So my answer would be 8 minus 4 times 2 squared is 4 plus 5. So the answer to this limit here is just the evaluation at that point, x equals 2, so 8 minus 16 is -8, -8 plus 5 is -3, right? Because remember, the limit is the y value, or the intended height in some places. Alright, for number 2. Number 2, if I try to plug into here, I get 4 minus 4 on the, I get, so actually I was saying I get, but I can actually just do that. I was thinking it was going to make 0 over 0, but it doesn't. So, I plug in 2, I get 4 minus 4 times 2 is 8. On the bottom, I get 2 minus 4, so -2. So I get -4 over -2, so I get 2. Right? For number 3, just go ahead and plug it in. Plug -3 into here. So I get -2 times -3 plus 1. So 6 plus 1 is 7. All right, for number 4, I'm trying to plug in -1. Also, it says I want the limit from the left-hand side. So -1, if I put that, I get 3x, so I get 3 times -1, so I get -3, and the bottom is 0. So this is a no-no. I can't do anything with this. So I have to look at a picture. Okay, so it's just one of the ones. I have to look at a picture. There's an asymptote at -1, so there's an infinite discontinuity, but I have to go ahead and see what the limit is. All right, so I do have that all ready to go. So here it is. I'm approaching -1 from the left, and so you can see here that it's rising, rising, rising. So I'm going to say positive infinity. All right, the next one, again approaching -1. There's an asymptote at -1 as well for number 5. So we're approaching just -1 in general. So here's that graph. So when I approach -1, one side is going up, the other side is going down. This is a disagreement. So I'm going to have to say this does not exist. All right, remember, DNA does not exist. Number 6, when I try to plug in 2, let's try that first of all. So I get 2 minus 3 is -1. On the bottom, I get 4 minus 4 times 2 is 8 plus 4. So actually, I get -1 over 0. So again, can't really look at that. So I'm going to go ahead and look at the graph. So x minus 3 on top. So here's that picture. Okay, so I'm approaching 2. Now, these are going to -infinity, but they both agree. So as I approach 2 from both sides of the graph go to -infinity, so I can say -infinity. All right, number 7. When I try to plug -2 into number 7, if I try to do that, I end up getting 0 over 0. So this is usually the case where I'm going to have to factor. And so this does factor. X plus 2 on the top, the bottom factors into x plus 2 and x plus 1. So these cancel. So this turns into the limit as x goes to -2 from the left of 1 over x plus 1. And there's no reason that I can't just plug in -2 into this expression. It doesn't matter that it has a from the left in there. So if I plug in -2, I get 1 over -2 plus 1, so 1 over -1, which is -1. For number 8, if I try to plug in -3, I end up getting 0 over 0, which usually means I have to factor, and in this one I can factor. At the top, x plus 3 and x minus 3. And the bottom is x plus 3, so they cancel. So this turns into the limit as x goes to -3 of x minus 3. So now I can plug in -3, and -3 minus 3 is -6. All right, again, number 9. If I try to plug in -2, it turns into 0 over 0, so I factor. All right, so I get, take an x out of the top, which leaves x plus 2. The bottom is x plus 2, so those cancel. So this turns into the limit as x goes to -2 of just x. So plug -2 into x, and you get -2. For number 10, if you try to plug -3 into here, you get 0 over 0. So let's try some factoring. X plus 3. The bottom is x plus 3 and x minus 1, so those cancel. So this turns into the limit of x going to negative 3, 1 over x minus 1. And now I can plug in negative 3. So negative 3 minus 1 on the bottom is negative 4, so I get 1 over negative 4, or negative 1/4. All right. So down here, number 11, x goes to 3, so I'll just plug in 3, because it didn't seem like that would be a problem. So on the bottom, I get 9 plus 3, which is 12, so I get 6 over 12. 6 over 12 is 1/2. For number 12, why don't I just plug in negative 1 right here? So negative 2 times negative 1 plus 2 square root. So I get 2 plus 2, which is 4. Square root of 4 is 2. For number 13, now this is changing a little bit. X is going to infinity. Now, when x goes to infinity, that just means the right side, the end behavior of the right side. So this is a parabola, and I didn't graph this one because, you know, wherever this parabola is, it's like facing, it's upside down, right? So the right side and the left side are going down. So I'm going to say negative infinity. For number 14, now in class, I showed you a way of doing this. When x is going to infinity, remember we multiply by 1 over x squared, multiply by 1 over x squared. You can do that, but for the test, I will let you go ahead and instead of doing that method, I'll let you use your horizontal asymptotes. Right? So this is a rational function. The horizontal asymptotes have to do with the numerator and the denominator, the degrees. The degree in the numerator here is x to the first. The degree in the denominator is x squared. So that means that my horizontal asymptote is 0. So that means that this goes towards 0 on the end, on both ends. But let's also look at a graph. We got 4x over x squared plus 4. So there it is. And look at that purple one. And look, it does go to 0 on both sides. Okay, so you can look at a picture or just know your asymptote rules. All right. So same thing here for number 15. As x is going to negative infinity, that's the left side. So my asymptote rules tell me this. The top and the bottom have matching x's. So my horizontal asymptote is the leading coefficients, y equals 2 over 1. So the answer is going to be 2. We can look at a picture on the left-hand side. And you see how it's going towards 2 right here. All right. So next one, number 16, same thing. It says 2 from, oh no, actually different, it's not infinity, 2 from the left. So 2 is going to be one of the vertical asymptotes. All right, so let's just take a look. We're looking at 2 from the left, and let's take a look at this picture. So from the left of 2, that's this piece right here, it's going down. So we'll say negative infinity. Oopsie. No. All right, there we go. Okie doke. So on the home stretch here, 2 over x minus 2, I can't plug in 2 because I get 2 over 0, so I should go ahead and look at the graph. So from the right side of 2. So the right side of 2 is rising up, so I will just say positive infinity. All right. Number 18. Going to 3, so again you get 2 over 0 or negative 2 over 0. So you can't like do a plug-in, you have to look at the graph. So let's take a look. Just 3 in general. Okay, so at 3 there's disagreement. One side's going down, the other side's going up. So I will have to say it does not exist. Alright, why is that little thing doing that? I don't know why it's making that weird circle thing. Anyway, all right. This guy here, when you plug a negative 2 into here, you end up getting 0 over 0. So this implies probably some factoring. So the top is x plus 2. The bottom is x plus 2 and x plus 1. So it's canceled. So this is in fact the limit as x goes to negative 2 of 1 over x plus 1. And now that that's canceled, I can just plug in negative 2. So negative 2 plus 1 is negative 1. So 1 over negative 1 is negative 1. All right, and looky here, just a polynomial. Let's plug in 0. So this goes to 0, that part's 0, so the only answer left is 7. All right, so this next page has some discontinuities. and you are to name the type of, I guess the directions are on the other page. That's strange. No? Oh, does it say? Okay, so the directions here are to tell me where the discontinuity is and also name the type of discontinuity. I don't know why it didn't do that. Oh, I'm sorry. No, it's right here. I'm trying to do a limit. I was thinking of the next section. So here's the question. Each of these problems has a question. I'm sorry, it was just like too much there for a second. So here's my question to answer. Here's my question to answer. Here's my question to answer. And here's my question to answer. All right. And, you know, the function's already graphed for us. I'm not going to make you graph that. But let's take a look. So this one says I'm going to 1 from the right. So that means I'm approaching x equals 1. So x equals 1 from the right. So that means that I am trying, let me get my little pen here. I am trying to go to this place, x equals 1, from the right. So that means I'm going to follow this guy right here. From the right, he comes up, and he comes down, and there's his answer, -1. So my answer in this case is -1. Okay. Over here on number 22, I am trying to approach -3 from the left. So that means I am approaching this space right here. I'm approaching from the left. So I'm going to use this piece right there. From the left, it comes to a height of 0. So that means my answer is 0. Okay, these two down here. This one says limit as x goes to -2. So just -2. So I'm trying to approach -2. So that is this line right here. Okay, so notice the difference though. One side comes down to -5, the other side comes to +7. That's a disagreement. Like, which one would I write? So I'm just going to put does not exist because you have to agree. All right, and this one is x goes to 3. So we are trying to approach this line right here, x equals 3, this place. So they are both coming to the same place. Even though it's kind of weird to have a line here and then a line coming up the other way, they're still going to this place right there, which is -4. So the answer is -4. All right, these next few, you're just going to tell me what kind of discontinuity that you see. So I see an infinite discontinuity at x equals 3. So x equals 3, infinite discontinuity. All right, here I see a hole happening at x equals -2. So x equals -2, I see a removable. Remember, removable is the hole. All right, this one here, number 27, I don't see any problem at all. This is continuous. Okay, I have a little too many letters in that word. Continuous. Oh, maybe not. That just looks strange. All right, over here, I'm trying to, -2, I have a jump going on right there. So -2, I have to jump from here to here. So x equals -2, this is a jump. So just being able to identify those. Alrighty, so down here we're doing some derivative work. So this problem down here says to use the limit definition of the derivative. So remember that that is the limit as h goes to 0. Got f of x plus h minus f of x all over h. Okay. So here we go. For f number 29, I got the limit as h goes to 0, f of x plus h. So that would be 3 with x plus h put inside minus 4 minus f of x. So minus this problem here. So it'd be minus 3x and minus 4 turned to plus 4 all over h. So when I look at that, it simplifies down. Well, actually, let me work this out a little bit. This would be 3x plus 3h up there. So then the 3x's cancel, the 4's cancel. So what I'm left with is the limit as h goes to 0 of, the only thing I have left is 3h over h. The h's go away, so the answer is 3. And frankly, you knew the answer was going to be 3 because, look, the derivative of a line is the slope of the line. All right, for number 30. So for number 30, we got the limit as h goes to 0 of f of x plus h, so 2 x plus h squared minus 5, that's f of x plus h, minus f of x itself. So minus 2x squared, and minus a minus 5 turns into plus 5. So already I notice that the 5's go away. All right, and the bottom is h. All right, so let's do just a little bit of cleanup here. I got this expression there, so 2, and if you multiply that out, x plus h squared, we did that in class, it comes to x squared plus 2xh plus h squared. All right, so what I get from here is I get the limit as h goes to 0 of 2x squared plus 4xh plus 2h squared, and then I still have minus 2x squared over h. Alrighty, so these 2x squareds, they go away, and then everything else has an h in it, so I'm going to cancel the h's. I'm going to say my limit as h goes to 0. This h cancels with that h, so I got 4x. One of these h's cancel with that, so I got plus 2h. So now I'm able to plug 0 in, and so this piece right here goes to 0. So the answer is 4x. Frankly, you knew that already, so that's a formula for the derivative. And you knew that already because you guys already know how to do the derivatives of things like this with the rule that I'm about to use down below. All right. So here we go. So we're just going to use our power rule here to do my derivative. So y prime, remember 2 times negative 8 is negative 16. Take 1 away. 1 times 9 is 9, and take 1 away, so no x left, and 5 just disappears. For number 32, the derivative of a constant is 0, because remember that this is x to the 0, so 0 times 9 would be 0, and then x would disappear. All right, so here, y prime, I get negative 30, that's here times here, x to the 4th, plus 8, x to the 3rd, minus, remember, negative 4 is multiplying by minus 1, so actually this can be a plus 4, x to the negative 5, because I take 1 away from negative 4, that's negative 5. All right, so we have some fractions coming up, so 5/4 times 8, so 8 times 5/4, 4 cancels out, makes 2, so I get 10, so it's 10 x to the 3rd, plus 3/5 times 1, so 3/5, x to the, I need 3/5 minus 1, so minus 5/5. So 3/5 minus 5/5 is negative 2/5. And then the 6 disappears. So there's my derivative. All right, number 35. Let's see, my derivative is, this is a 1 here, so 1 times 1 is 1, the x goes away. The 8, the derivative is 0. And then here I got negative 3 times 9, so negative 27, x to the negative 4. Take 1 away from negative 3. All right, here my derivative, 1/4 times 2. So 2 times 1/4, these cancel to 2, so it's 1/2. X to the 1/4 minus 1, so that's 1/4 minus 4/4, so it's negative 3/4. Right, and then I got negative 4 times 5, so it's negative 20. X to the negative 3. Oh, no, wait, I'm sorry, not negative 3. Take 1 away from negative 4, and you get negative 5. Okay, and these two at the end here, they are similar, it's just you have to, I wanted you to be able to put that in the right form. So remember that this piece right here, so 3x to the 5th plus 2x to the negative 3, this piece you would change to 2x to the negative 4. So that's still my function. Now I'm going to go ahead and do the derivative. So I'd get 15x to the 4th minus 6x to the negative 4 minus 8x to the negative 5. And I'm multiplying and taking 1 away. Over here, my derivative, 5 times negative 4, negative 20x to the 4th plus 10x, and the 1 disappears. Okie doke, so that is it. Oh, and if you need it, here are the solutions as well. You can look through there. Hopefully I got them all correct. Alright, and there are your answers. If you want to pause and look at anything, I'll put them up there too. And there's all those those derivatives. Now the book tends to write them back like this. I don't care. You can leave this like I wrote it. It's fine with me. All right, that's it. Bye-bye.